Hello guys, in this video we are doing identities. So I want to start with the first identity that we have, which says cos squared theta plus sine squared theta is equal to 1. Sine squared. So this is the first identity that we have. To prove this identity, that sine squared theta plus cos squared theta is true, we prove it like this. This is our triangle. I want to draw here. Then it's a right angled triangle with our angle theta. This is our x-axis, this is the y-axis. So we can take this distance from here to there, we can make it x. But let me make it x. Then this one from here to there is changing y, so I can make it y like that. This one I can make it z. Then from there we need to find sine theta and cos theta. These are trig ratios that we are applying. So sine theta is equal to, sine theta is opposite of our hypotenuse. This is our opposite, this is our hypotenuse, this is our adjacent side. So it's y over z. That's sine theta. Then cos theta is equal to adjacent over hypotenuse, which is x over z. So now I want to see cos squared theta plus sine squared theta. We want to see whether this one is going to give us 1. If it gives us 1, then it means it is true. So from there, this is our sine theta. So we have to square sine theta. It will be y over z squared plus x over z squared. Then y squared, get y squared over z squared plus x squared over z squared. Then we add these ones. The denominator is common, so we just add the top number, z squared, then y squared plus x squared. So at this stage we have y squared plus x squared is equal over z squared. But as we need, we know that we have to find out what is y squared plus x squared. So we can do it like this. By Pythagoras theorem, it states that x squared plus y squared is equal to z squared. Plus y squared is equal to z squared. So in this case, this is y squared plus x squared. So it is equivalent to z squared. So it will be z squared over z squared, which is equal to 1. So we have proved our identity, cos squared theta plus sine squared theta. Now let's see what's next. We can play around with our identity to derive some identities that can come out from there. We mark it identity 1. Number 2, we can divide by cos squared theta throughout this equation. This divide by cos squared theta over cos squared theta over cos squared theta. So this one it cancels and gives us 1 plus sine theta over cos theta, we get tan theta. So this will be tan squared theta. Then we have this one, 1 over cos squared theta. 1 over cos now is equivalent to sec theta. So this is, since it is cos squared, so it gives us sec squared theta. So this is the other identity we can find from the first one. And another one, we can divide by sine squared theta throughout again. And let's divide and see what we get. Plus sine squared theta is equal to 1. Divide by sine squared theta throughout. Sine squared theta, sine squared theta. This one, cos over sine, it gives us cot theta. So this is cot squared theta plus sine squared over sine squared, it gives us 1. Is equivalent to 1 over sine is equivalent to cosec theta, but since it is sine squared, so it's cosec squared theta. So these are identities we can derive from our main identity, which is this one. Now let's see the next part, which is compound angle identities. Compound angle identities. A compound angle is two or more angles that are combined together to form one angle. For example, can be given theta and alpha. They can compound to form one angle. So now let's see the identity of sine theta minus alpha. So this one, it is equivalent to sine theta cos alpha minus sine alpha cos theta. So this is the identity of sine theta minus alpha. Now I want to see the identity of sine theta plus alpha. We want to derive it using this identity for sine theta minus alpha. So what we do, we know that plus can be made by two negative signs multiplied together. So this one can be written as sine theta minus alpha, like this. This is the same as theta plus alpha, because negative times the negatives gives us a positive. So now we work with this one. So our angles that we have theta and minus alpha. We don't have alpha in this case, it's minus alpha. So wherever we have alpha, we have to substitute with minus alpha. So this one will be sine theta cos minus alpha minus sine minus alpha cos theta. Then this one, cos negative theta. From reduction formula, we know that negative alpha, this is a negative angle which is found in the fourth quadrant. So in the fourth quadrant, cos is positive. So this is sine theta. So this one will reduce to cos alpha. Since we said in the fourth quadrant, negative theta, negative alpha can be simplified to cos alpha. Alright, let's see this one. This is negative alpha. It's still fourth quadrant. So is sine positive or negative in the fourth quadrant? Then sine is negative. So this will reduce to negative sine alpha cos theta, which is equal to sine theta cos alpha, negative and then negative give us a positive, sine alpha cos theta. So this is our identity for sine theta plus alpha. So sometimes the question can ask you, use the identity sine theta minus alpha to derive the identity sine theta plus alpha. So you are deriving the identity for this one using the previous one, which is for sine theta minus alpha. So this is how we're deriving it. That will be our final answer. So at this one, you find it on the formula sheet, written sine theta plus alpha. But in case if they ask you to derive it, you need to follow this step. Let's see the identity for cos. Now it's cos theta minus alpha. So in this case, the identity for cos theta minus alpha is cos theta cos alpha. If the sign is negative, it should be positive this side, which is plus sine theta sine alpha. So this is our identity. So we want to use this identity to derive the identity of cos theta plus alpha. This one is minus minus. So we have cos theta minus alpha. Now we can use our formula for the previous identity. So this is equivalent to cos theta cos negative alpha plus sine theta sine negative alpha. So this one, cos negative alpha, is in the fourth quadrant. So but cos is positive in the fourth quadrant. So this will cos theta cos alpha plus sin theta. This one, its sign in the fourth quadrant is negative, so it reduces to negative sin alpha, which is cos theta cos alpha. So this sign is simplified to negative, which is sin theta sin alpha. So this is how we derive the identity of cos theta plus alpha from identity cos theta minus alpha.